All right, good evening, geometry students. I appreciate you finding time on your busy Halloween evening to get your notes taken care of. Okay, we're going to be spending the next couple of days, actually the next several weeks, looking at a lot of things about triangles. Okay, there's a lot of rules and special things about triangles that you guys are not aware of yet, but that's going to be a huge part of what we're doing here in Unit 4. We're going to spend the next couple of days looking at some of the basic properties of triangles. You may be familiar with some of this, but others you may not be. Okay, so let's get started. Our objective for Friday will be the student will discover the relationships between the angles and the sides of all triangles. Again, these are the notes for Friday, November the 1st. So please copy down your objective and your date. As always, press pause anytime you need more time to copy something down, and then hit play when you're ready to move on. Okay, now all triangles carry certain properties that go along with them, and we're going to be looking at a couple of the cornerstone properties for all triangles today. The first one we're going to look at is the relationship between the measurements of all sides and the measurements of all angles within a triangle. Okay, and the basic rule is really a very simple one. Okay, it says in any triangle, the smallest angle and the smallest side are always going to be across from each other. Okay, and that will hold true also for the largest side and the largest angle, the medium side and the medium angle, and it'll also hold true for congruence. If you have two side lengths that are congruent inside of a triangle, that is going to mean that you will also have two angle measurements that are congruent inside of that triangle, and they will always be positioned so that they are across from each other. Now we're going to be looking at several examples. Okay, so those of you that have made it a habit here lately of skipping all of the examples and only writing down the sentences, that is proving to be a very bad strategy for you, because let's face it, the grades have not been that good. So let's quit cutting corners on our notes and start writing things down. Okay, so copy this example down. Okay, and we've got a triangle here. We have a very straightforward question that is asking us which side is the longest side of the triangle. Okay, well, as you're jotting it down there, a couple things to think about. First off, we cannot eyeball these triangles or any of these shapes and judge them based upon the way that they look. That's a very bad strategy in geometry, and it will frequently lead you to the wrong answer anyway. So we don't really care how the triangle looks. We care about the math. We care about the numbers that exist within the triangle. Okay. Secondly, it's a question about side lengths. And when we look at the figure here, we can see very quickly that we do not have any side lengths in the triangle that are marked for us. Okay, so that puts us in a spot that until now, it would be impossible for us to decide which side is going to be the largest. But we have a new rule, and this rule tells us that there's a relationship between the angle measurements and the sides, that if you are looking for the largest side of a triangle, that all you have to do is locate the largest angle of the triangle, and that will be, your side length will be across from that angle. Okay, so look in the triangle. Which angle is largest? Obviously, the angle that is near vertex C. Now, keep in mind, guys, we use the three-point naming system for our angles. Okay, some of us have gotten a little bit spoiled here in the last unit because our angles tended to be numbered for us, so we could just call them by that number. Okay, but angle ACB is the largest angle in the triangle. Okay, so across from it is this side that is marked with the little lowercase c. That should be the side that is the largest because it is across from the largest angle, angle ACB. Okay, so side C, or you could also call that line segment AB. Okay. Now this can be reversed and looked at from the opposite direction. Here's a different example. Copy it down. Which angle is the smallest? Well, once again, you can't look at the triangle and eyeball it. You can't decide it that way. Okay, and when we look at the triangle a little bit deeper, of course, we see that we do not know any of the angle measurements. But we have this relationship. The relationship tells us that the smallest angle in the triangle will always be across from the smallest side. Well, very clear to see that the smallest side in the triangle is line segment BC. It's only 6 units long. And across from line segment BC is angle CAB. Angle CAB is the smallest angle since it is across from the smallest side, which was line segment BC. Now, as you can imagine, this can get a little bit more complicated. Okay, they can ask a lot deeper questions than simply which side is the biggest or smallest, or which angle is the biggest or smallest. So consider this example for a second. Classify the following triangle. Okay, well, that's what we've been doing for the last couple of days, classifying triangles and polygons. Okay, so now we are going to consider the information that we have and see if we can come up with a classification for it. Okay, well, obviously there is a classification you should be able to tell right off the bat. We have all three angles are acute angles. Okay, now remember, all triangles are going to have two acute angles, but what does it mean if you have all three acute angles? Of course, that means we're going to have an acute triangle, so that's going to be part of our classification. We're going to be acute. Okay, but there should also be at least one term that describes the side lengths for this triangle. Okay, well, obviously we don't have any side lengths to go on, but we do have the angle measurements. And one of the things we need to notice is that inside of our triangle, we have two angles that are the same measurement. That is going to mean that across from those two congruent angles, we are going to have two congruent sides. And what is the term that says for triangles that says you have at least two sides that are the same measurement? That term was isosceles. Okay, so this triangle is acute. All three angles are smaller than 90, and it is isosceles because there's going to be two sides that are the same length. Okay. Now, another relationship that we have inside of all triangles, and you may be familiar with this one already, but copy it down anyway. Okay, this one deals with the interior angles for any triangle. And the rule says that the interior angles in any triangle are always going to add to 180 degrees. Okay, so here's a diagram that goes along with that rule. Okay, any triangle, the three angles that are inside of it are going to add together to equal 180 degrees. Copy down the definition, copy down the diagram, copy down the rule. Okay, quit cutting corners in your notes. We're not doing a very good job of learning, and cutting corners on the notes is not going to help. Okay, so based upon this rule, let's see if we can work a problem or two. Okay, so here's an example. We have a triangle. Some information is provided, some is not, and our instructions are to solve for x. Okay, well, one of the most important things that, one of the most important questions you're going to be asking yourself in geometry over and over and over again is, what do I know about the picture? Okay, well, obviously, we're supposed to solve for x. X is one of the interior angles in the triangle. So we go, okay, what do we know about the interior angles in a triangle? Well, based upon the rule we just said, the interior angles in a triangle should all add together to equal 180 degrees. So that's our equation. The 70 degrees that we know in the triangle, the 90 degrees that we know because of the little right angle box, and then the x that we do not know, they should all add together to equal 180 degrees. Now we just solve for x. Okay, parents' complaints vary for everyone. Okay, we're going to work through. The first thing we're going to come to is some like terms on the left side. The 70 and the 90 can combine for 160 degrees. And as you continue working through your steps, the next thing you'll come to is that 160 does not need to be attached to our x. So we're going to move it to the other side by subtracting it. Subtract 160 from both sides, and that very obviously leaves you 20. Okay, x is 20 degrees because the three angles in a triangle need to add together to equal 180 degrees. It's really that simple. Okay, but as you can imagine, they can do all kinds of things with these questions. Okay, so let's take a look at one like this. Very similar question, okay, in the picture. As far as this is concerned, we have interior angles in the picture. Some of it information we do know, some of it we do not know, but the question is on a much deeper level. What is the largest side of the triangle? Okay, well, we do not have any side links to go on, but we know that there is this relationship that exists between the angle measurements and the side links. So if we can find out what's going on with the angle measurements, that puts us in a position to answer the question about the side links. So let's work on the angles. Okay, we're looking at interior angles of a triangle. So what do you know about the interior angles of a triangle? They are supposed to add together to equal 180 degrees. So 25 plus whatever 2y is plus whatever 3y is should equal 180 degrees. Now we work through our steps for solving an equation. Parents' complaints vary for every one. Okay, parents, parentheses. Got any parentheses or multiplication in there? No, nothing there. Okay, complaints, combine like terms. Hey, look, we've got 2 y's on the left. We've got 3 y's on the left. How many y's is that on the left? There are 5 of them. Okay, parents' complaints vary. Move all your variables one direction. Well, the y's are already together, so we don't have to worry about that. Okay, parents' complaints vary for every. Every is everything else moving the other direction, so that 25 does not need to be there. So we would subtract 25 to the other side. 180 take away 25 is 155. The fifth and final step of solving the equations is the 1. Okay, we want a positive 1 coefficient for our y. We do not want 5 y's, we just want 1. So how do you move the 5 but leave the y? Okay, by dividing it. Okay, so we're going to divide both sides by 5, and that will give us 31. Okay, that's great. Y equals 31. Did the problem ask us to solve for y? No, the problem asked us about which was the largest side of the triangle. So we better see if we can't figure out which is the largest side of the triangle. Okay, so in our triangle, we had some y's on some interior angles. We now think that y is 31. So what we're going to do is we're going to replace y with 31 on each of these angles. And when we do, we end up with some measurements. Okay. Now, the question is asking, which is the largest side of the triangle? Well, where should we look for the largest side of the triangle in this picture? The largest side of the triangle should always be across from the largest angle. And the largest angle is angle ABC. So that is going to mean that the largest side is going to be line segment AC. Okay, so you can see how these problems can get a little bit in depth. There's a lot of steps to them, but as you can see, none of the steps is really all that difficult, and that's the way geometry goes sometimes. These problems can get long, but it doesn't mean that any particular part of the problem is really that difficult. You just got to keep after it. Okay, the last thing I want you to do is I want you to copy down this example. Okay, and this one obviously has a lot of stuff, and our instruction is to classify the following triangle. I want you to get it copied down, and I want you to take about 2 or 3 minutes, which is probably about all it will take. I want you to see if you can solve the problem and see if you can get a classification. That is the end of the notes. Okay, copy the problem down, work the problem out. I will expect to see some effort on this in your notes tomorrow if you want your notes to be considered to be complete. Have a good night, and we'll see you in class on Friday.